Hello and welcome to this case walkthrough of this case called Whack-A-Mole. It's from the 2023 Road to Las Vegas. It was the first battle, so this is a little bit before my time, but I am going to do my best to do a walkthrough explaining how I would solve this, having now done it a few times. So all the usual caveats. I've done this a few times, gone through, in some cases even looked at some of the walkthroughs that other people have done, so not covering anything new here. And like I said, this is how I would do it knowing what I know now, which is obviously not the same as what I would do on the first view, which is a very different beast. So just a little bit about this case. I'm assuming if you're watching this, you're someone who's either had a go or about to have a go at this. So there's not a huge amount of other data needed for this. All we've got is this second tab, which has a 15 by 15 grid with various codes which are explained in the case. We've got column letters and row numbers just to help us if we need those, although I don't think I'm actually going to use those. And it's only 5 levels, so being 2023 case, unlike the current ones which have 7 levels and only 3 bonuses, but still plenty to get your teeth stuck into. It is a developmental case in the sense that each level builds on the previous level, so you wouldn't really be able to get onto the high levels if you don't do the first few levels, or if you did, it would be very difficult to. And if you don't get everything right on the earlier levels, it would be very unlikely that your model would work for the later levels, although still theoretically possible. So yes, I'm confident this can be solved within half an hour, so I don't think it will take that long. So I will do a little bit of explanation as I go, but I'm going to assume a certain level of starting knowledge on cases and Excel sort of techniques and so on. But I think I've said enough now. Let's get going. So we're going to switch over to our score sheet, click start, and let's get going. Okay, so the first thing I'm going to do is I'm going to go to the grid, which is here, and I'm going to name this as a named range so that I can use that throughout. I'm just going to call this board to reference the board, and then that's all we need to do for that. And then let's go up to level 1. So there are a few explanations, but I think I'll go through them as we go through, but the first level is simply asking us to tell what the listed cell contains. So if we went to D40, we would find X5. So I'm going to import my lambdas, and I'm going to use my address lookup lambda. So I'm going to look up within the board, returning the cell that's just there, and then I'm going to fill those down. I'm going to copy that over to the score sheet. We get our 60 points, so that's a nice, easy, simple start. So level 2, how many points are earned by hitting the 20 cells in the listed order? So I'm going to create this as a data table. I'm going to zoom in a little bit. So I'm going to start off with my cells. So these are what I'm hitting. So this, I'm just going to text split what's in B1. Actually, it's not a B1 hash, so B1 with the semicolon. And that tells me the 20 cells I'm going to hit, so that's 20. And then I need to work out what am I actually hitting. So I'm now going to use the same formula I used a moment ago. So I'm going to use address lookup, referencing the board, referring to these cells, and then I'm going to fill that down. That tells me all the things I'm hitting. And on this round, I'm only interested in, it says multipliers, resets, and reverses do not apply. So from the rules of the game, that basically means we're only interested in the cells that are a mole that begin with an M and then the number that comes after it. So all I'm going to do here is I'm going to have a column for score. I'm going to say I want to take the text after, from this cell, anything after an M dash, and because it's going to be returning text, I'm going to multiply by 1 to give me a score, but that's going to return errors whenever I have nothing or when I don't have an M. So I'm going to wrap that inside an if error. And if it's an error, I'm just going to return 0 because we don't want any points. And then when I fill that down, we get 52 where there's 52, 94, 87, and so on. So we know it's working. And for this, we just need, we've got no multipliers, no reverses, no resets. So we're just going to take all of the points. I'm just going to sum this range. Gives me 384 the example. And we'll copy those over to the score sheet. and we get 160. So level 2, relatively straightforward as well. Level 3 is where this is going to start getting interesting, because now the multipliers and the resets apply. So when we go to level 3, which again I'm going to start with a data table, I'm actually going to take my workings from level 2 as well. So I'm going to select those whole columns, go over to level 3, paste those as a starting point, and the first thing I notice is that we now have 30 instead of 20. So let's just take those two columns and fill them down. So we're still getting the points out, but that's not going to be the only thing we need to look at. We also need to look at resets and multipliers. So let's start with multipliers. So let's do something similar to before. So we're going to wrap this inside an if error. We want to take the text after from here, and we want to take anything after an x, multiply by 1 so we get a natural value. And if we don't get anything, then we're going to assume the multiplier still needs to be 1, because if we have points, if we set it to 0 and we multiply by points, we'll get nothing. So let's set that to 1, and we see that on this particular question we only have one multiplier down here, so we get 5 for that. And I just need to check, because I think on this level resets and multipliers are added, and that means that once a reset or a multiplier has been hit, in fact anything other than a mole that gets hit disappears off the board. So we now need to have a way of tracking that as well. So let's go to our model, and we're actually going to insert some space here. So what we want to do is we want to check whether any of these cells have come before. If I just quickly add some conditional formatting, we see that some of them are repeated. So G1 on this second time through, this VV, which doesn't count within this level but shouldn't actually be included. So we've got to find a way to exclude that. So what we're going to do is we're going to say, which way around am I going to do this? I'm going to actually insert this over here. So I'm going to say I want to count ifs these cells up here have contained the value in this cell. And I'm going to fix the row 3 so that when I fill that down like so, we get ones where they have appeared before. And what we're going to do is we're going to apply some logic here. We're going to say, firstly, if our value is equal to 0, so if it's never come before, then we can take what's given to us in the hit, which is what's here. Otherwise, we're going to leave it blank, so we don't want to return that. And if I fill that down, we find that on this second RR it's disappeared, but this logic would also be being applied to our moles, which we don't want to include, so we need to have an exclusion for those. So what we're going to say is, if the left of what's in I5 equals M, in other words, if it's a mole, then we want to return what's in I5. Then we go into our separate logic about whether it's happened before. So we can fill that down. Now, it won't change anything on this particular level, but for other levels that will become important. So I'm going to call this used before. So this excludes those that's used before. And now our score sheet needs to actually refer to this cell. And the same here with our multiplier, because we don't want to refer to the original because we might not actually be counting. Now again, on this level it doesn't really make a difference, but on later levels it will. So we can see that's now applied the logic here. We now also need to apply our logic that the fact that multipliers can be cumulative as well. So I'm going to start with a 1 here, and I'm going to call this multiplier 2. And my logic here is going to be that if this equals reset, then we go back to 1. If the previous go, so if this previous go was a mole, then we have reset. So if the left of that equals M, then we're going to just take whatever the current multiplier is, because it may be greater than 1, but we can't multiply with the one before. Otherwise, we're going to take the previous multiplier and multiply it by the new row. And if I fill that down, we see that on that last row, we set the multiplier at 5, and then we're going to use it on that next one. And if we had another go, it would then reset, but it's not going to do that. And so then our points on each level is going to be the multiplier times by the score, which again, if we fill down, we'll get lots of zeros, but anything where we get points, we get our multiplier. And on that last one, we get 14 times 5, which is 70. But then our actual score, or running total, shall we call it, I'm going to actually put that above here because we start off with 0. If we have a reset, so if h5 equals reset, then we go to 0. Otherwise, we add the previous with the current. And then when we fill that down, that's our running score. And we can see that that last one there, which I'll put in bold, matches our example. So I think we're in good nick. So I'm going to say equals that. I'm going to take my answers, go over to the score sheet, and we're good to go. All correct. So let's carry on. So that was good. That's a lot of hard work has been done there. So now we're on to level 4. And in level 4, it's the same as before, except we now include the grid shift. So this is a concept that's quite hard to get our mind around. So what it's saying, if we go to the grid, it's split into kind of 9 quadrants. And I might just quickly draw on this for a moment. It's saying that if we hit, for example, this section here, then everything in the grid moves in that direction from the middle. And what that actually means is if we're still looking at a cell on our next go, so let's say we were looking at this cell on our next go, the M35 has moved up here. So actually we will be interested in what previously was in the opposite direction, because this RR has now moved up into here. So that's the kind of logic that's being applied here. So we need to identify which direction the shift is and then apply the opposite of that shift to what we're looking at next. And so the way I'm going to do that is I'm going to start by building a data table, but I'm going to grab all the workings I did on the previous level as our starting point, put those in the same columns as before. Okay, and now we've got to worry about shifting. So we're going to shift by row and column, and the starting point is to work out which segment we're in and what we're going to do. And a little insight that came to me after doing this case the first time was, and I'm going to actually insert an extra couple of rows here, is that basically in the grid, it's kind of split into, we've got columns 1 to 5, then 6 to 10, 11 to 15, and same with the rows, and we can use that kind of row number and column number to tell us what to do. So if I do a little lookup here of 5, 10 and 15, and if the row or the column is 5 or less, then we're going to shift by 1. If it's between 6 and 10, we don't shift it, and if it's 11 to 15, then we do shift it by -1. So what I'm going to do is I'm going to start by taking the row number of this cell, and then what I'm going to do is I'm going to wrap that inside an XLOOKUP, and I'm going to XLOOK that up on this range here. I'm going to lock that in and return from this range locked in, and I want this exact match with the next larger item. And if I fill that over to the right and change row number for column number, and also change G7 for F7, we see our actual movement. And then what we actually need to do is kind of have a cumulative version of this same thing, where we're going to say, right, I want to have the sum of this section here, but I'm going to again lock the row. I'm going to fill that right, and let's just take all of this and fill down. And what we can see that in this first 2 columns we're only getting 1s and 0s because we're only moving 1 at a time, but in this section we're getting cumulative scores, so we're ending up with stuff that's bigger than -1 and 0, so we're getting 4s and 3s and 5s, although in this case it's minuses. So that's the kind of cumulative effect of each of these individual shifts. And we're going to need to insert a couple of columns here because we now need to adjust what we're hitting based on the cumulative effect of those shifts. So what I'm going to do is take row, column, and a cell. So I'm going to take the row number of this value, and I'm going to add the cumulative effect from the previous row, and I'm then going to wrap that inside a mod, because we might theoretically, well, not theoretically, we do end up in situations where we go outside the range. So I'm going to do mod 15 minus 1 plus 1 to keep it within 1 to 15 rather than 0 to 14. And then when I fill that right, let's change that to column number and change the original cell to F7. We should get the correct column number. And then what we're going to do is take an address of the row and the column number 4. And this is where my duplicate values is going to get pretty annoying in a moment, because when I fill these down, we get tons of duplicate values. So let's just quickly remove that rule for now. And so what we see on the first row, because there's no shift, we look at A2 and that's where we genuinely want to look at. But on the second one, we're told to hit I15, which is here. But because everything on the previous round shuffled up and to the right, we need to look at what was below it and to the left. And because that's outside the range, it means what's up here. So we're actually looking at what is in H1. Is it H1 or it's going to be J? Oh, I've gone the other way. Yeah, sorry, it's the other way. We hit A2, so we went up this way. So we're looking for what was here in J1, which is what we're actually looking at, which is J1. But we now need to tell this to look up the adjusted cell. And we need to make sure these are referencing the correct adjusted cells as well. So move this over there. And then when we fill those both down and just check, this is now all referring to everything else. I think so. Yes, our answer down there in bold is 481. So I think we're on the right track. So let's reference that cell. Reference cell P36. And let's take those values, go to level 4, and we got 220, so that's good. So now on to the final level before we attempt the bonuses. So this one is the same as before, but now we also have the issue of a reversal in direction. So there are certain cells that when we hit them, reverse the direction of all the shifts. So I'm going to select my whole model, go to level 5, paste that over here. So what I'm going to do here is I'm going to add a reversal column. And what I want to do here is I want to count ifs up until this row, or not including this row, we have had how many double V's have we had, which is our reversal. And again, I need to fix the row. So we're fixing at row 5. And if I fill that down on this example, we only have one reversal, which is here. And the impact only takes impact on the row afterwards, which is why when we're 1 here, the reversal is actually up there. And what I want to do is turn these zeros and ones into ones and minus ones, because I'm going to kind of basically multiply these row and columns by this. So what I'm going to do first is I'm going to wrap this in a mod of 2, which then means if I had ones that went, if I had multiple reverses rather than just one, just struggling to fill that out. It will always set to 0 or 1. And then the last thing I'm going to do is a little trick I learnt, can't remember where, but I'm going to take minus 1 to the power of this, and it's going to convert my zeros and ones into ones and minus ones. So then what I can do is in my row is I can multiply the row change by my reversal figure, and it will basically change the direction when we have change in direction. So when I fill that down, we get our things. And then the last thing to do, the reason I'm not getting the correct answer is because we have 10 more rows. And when I do that, we get our correct answer. So we're going to go over here and reference P46, select all of those, return to level 5, and we are good. Okay, just over 12 minutes left. So let's do the bonuses. So the bonus number 1 says what cell is the most frequently selected cell across all levels. So what I'm going to do is I'm going to take firstly I'm going to actually I'm going to do this inside a let. So I'm going to say let A be the 2col of V stack, and let's just manually select all the questions and put them all together. Help if I selected all of them. And then that's all my things. Then what I want to do is want to expand the formula bar. So I want to text join with a colon A, and let's call that B. And then what I want to do for C, I'm going to text split B based on colon, and then I'm going to group by C by count of all -2, and that's going to give me the whole range. So then I'm just going to put an @ symbol, we get M3. What is the total number of times the grid does not shift in level 4? So let's take level 4, let's make a copy of it, and we want to know how many times we get no shift. In other words, we get 0, 0 in the row and column. So how many times did we hit the middle sort? So I'm going to say I want to take and this equals 0 and that equals 0. I'm then going to fill that down, and then I'm going to take sum of those. So on this particular case, example, there's only 3 where we hit the middle. So we'll point our data table to that cell, and then we'll take the sum of all of the actual questions, which is 84. So we'll return to the case, that's 84. And then you play with the 4 rules on level 5 and hit the same cell 20 consecutive times, which cell gives the most points. So in other words, we'll take level 5, make a copy of it. Instead of the actual questions, we're going to take the 2col of the cell addresses of the board. So in other words, all the cell addresses, I'm going to copy and paste those as values just so we've not got too much computation going on. And then what I want to do is put one of those up here. So let's put cell A1 up here. And then instead of text splitting cell 1, what we'll do is we'll say if the sequence of 20 is true, then return the value in B1. So then we get 20 A1s in a row. Our model does the rest of the work, and our answer is what's ever in P26. So in this case 999. So let's apply our data table based on cell B1. Does all the work for us, and then we just want to know the max or the largest. So let's say largest and smallest. So we're looking up this range, returning this range. That'll give us the full thing. So let's just wrap that inside an @ and we get G13. Didn't mean to do that, I meant to go to the case. So those are our bonuses. Go to the score sheet for the bonuses, paste that there, just wait a few seconds for it to show that it knows what we've done, and we're good, and we're on 12:50, so we'll stop solving early. So 21 minutes that was talking through, so I'm pretty sure that could definitely be done in probably nearer 15 minutes. Certainly using the approach that I took, I don't think we could get much quicker than that. So but again, all usual caveats, that was solving after having done it a few times. When I tried this the first time under time conditions, from memory I managed level 1, managed level 2, I got most of level 3, but I think I had some trouble with the multipliers, and kind of there was a case where there was a multiplier straight after there had been a hit, and I set it back to 1 rather than setting it to the value of the multiplier, so I underscored some of them. And then I think I attempted level 4 because I didn't know I'd got level 3 wrong, so I attempted level 4, and again I think I still made some progress, but because my level 3 model was incorrect, lots of my level 4 was incorrect, but some of them, just by the particular combination of letters and numbers, they still came out right. I also didn't notice, so afterwards quite a few of these have 0 as the answer, and actually so if you had a reset quite close to the end of the model, or the sequence, you would likely to get the score anyway, because it didn't matter if your multipliers were wrong. So an interesting one there. Or if you put 0 on all of them, you'd actually still got 4 or 5 of them correct. So yeah, nice fun case that. Quite a tough one to think through, and definitely learnt a lot by doing this case. So anyway, thanks for watching.